In Chapter 9, we're going to look at the binomial distribution. This is a simple way to calculate probability under some very specific conditions. And by being able to calculate these probabilities, that'll enable us to better play around and understand hypothesis testing, which is what we're trying to be looking at now. The model for binomial distributions that we're going to use is a coin flip. Just a regular everyday coin flip, because a coin flip has certain things that are characteristic of binomial distributions. First of all, you can flip a coin as many times as you want. We'll call that number n. That'll be the number of coin flips that we do. On each flip, there's only two possible outcomes, heads or tails. And that's one of the reasons they call it binomial, because it'll go in one of two directions. Heads or tails could be true or false on a true-false test, could be right or wrong on a multiple choice test, but there's two possible outcomes. And on each flip, the two outcomes are mutually exclusive. You can't get both heads and tails at the same time. It has to be one or the other. You can't get both. There's independence between each flip. If I flip a coin one time and it lands tails, that's not going to influence how I flip the next coin, so they're independent. The probability of each outcome, and we're going to call that P, the probability for what we're looking at, and the other outcome, tails, which we're going to call Q, stays the same for each outcome. So with coins, it's 50-50, but it doesn't have to be that way. So a binomial distribution is any distribution which meets these five criteria, like a multiple choice test, whether some product is sold or not when somebody comes in. It's a bunch of things will fit this criteria. Note that it's not necessary that it's a 50-50 outcome, that P and Q, heads and tails, equals 50-50, but with flipping coins, it happens to be that way. Now let's look at a probability distribution of two coin flips. Let's just suppose we have two coin flips, and we're going to calculate the probability for each outcome. Suppose we want to find the probability of getting one head and one tail in any order with two coin flips. So the first thing we're going to do is we're going to create a table with all possible outcomes. So we could have tails and tails, that would be 0 heads. Tails and head, that would be 1 head. Heads and tail, that would be 1 heads. And heads and heads, that would be 2 heads. We want the probability of getting 1 head and 1 tail with any two coin flips. So we're especially interested in these two outcomes here in the middle. Now, let's make a probability distribution based on this table that we've made. So there's 4 possible outcomes. Tails, that's the same thing as 0 heads. There's tail heads and heads tails. Those are both 1 heads. And heads, which are 2 heads. Since there's 4 possible outcomes, there's only one that has the probability there's only one that has 0 heads, so there's a 1 out of 4 chance there. So there'd be a 1 in 4 chance of getting 0 heads. So we'd say the probability is 0.25. Same thing with 2 heads. That's only 1 possibility out of 4. That's 0.25. But the probability of getting 1 head, there's 2 possible outcomes there, and 2 divided by 4 is 0.5. So we'd say the probability of getting 1 head is 0.5. So this is a probability distribution in this box. It shows the probability of getting any possible outcome. So we can use this probability distribution to calculate things. If we want to say, what's the probability of getting exactly 1 heads? Well, we look at that table, and it's P equals 0.50. Now, what's the probability of getting 1 or more heads? We have to say, that includes 1 head and 2 heads, and we can add the probabilities together because they're independent and exclusive of each other. So the probability of getting more than 1 head is 50% plus 25% is 75%. We could also ask, what's the probability of getting something more extreme than one head? Oh, what does that mean? More extreme means farther in both directions. So in statistics, extremities always go in two directions, the two tails. So two heads is more extreme than one head, but we could also say that two tails is more extreme than one head. And two tails would be the same thing as zero heads. So both zero heads and two heads are more extreme than one head. So it would be 0.25 plus 0.25 equals 0.50. So there's a 50% chance of getting something more extreme than one head. Now, that's a way that we can calculate binomial distributions when probabilities for different outcomes when there's only two coins. But once there's more than two coins, it starts getting a little complicated. And so we're going to use the binomial distribution function in Excel. And this function has 4 arguments. The function is binom.dist, so the binomial distribution. And so to use this, you would put equal in front of it. And then in parentheses, we need to put 4 things. First of all, the number of p events. That's like the number of successes that interest us, the number of outcomes from the binomial distribution that we're trying to estimate the probability of. For example, the number of heads. And the second argument is the number of trials. I mean the number of coin flips, or the number of questions on a multiple choice test. P is the probability of a success, the success of what we call a P event. And so, for example, that would be 50% for a fair coin. If we were doing a multiple choice test where it's A through E and we were guessing, the probability would be 0.20 for getting an event by chance. So that's the third argument there is P, the probability, which for coins will always be 50% if they're a fair coin. And then the final question is cumulative. And this is a binary variable that we have to either mark as true or false. If false, if we just want to calculate the probability of getting the specific number of events. For example, if we wanted to get the probability of getting exactly 3 heads out of 7 flips, we would say, no, this is not cumulative. We just want the 3, so we would put false for the last argument here. However, if we wanted to figure out the probability of getting 3 or fewer heads out of 7 flips, we would want 0 heads, 1 head, 2 heads, 3 heads, and we would say that would be cumulative. Now, on the normal curve, we say that it's cumulative because if this was 3 here, we would want to know if we want to know the probability of getting something to the left of it, we would say, aha, that's cumulative. Everything from the table to the 3 point, which would be 0, 1, 2, and 3. So if we wanted to know the probability of getting some event and everything to the left of it, we would mark this as true. So how would we use this binomial distribution function in Excel? Let's concentrate on this question. What is the probability of getting exactly 3 heads with 7 coin flips? Well, there's the 4 things that we need to know to use the binomial distribution, the 4 arguments that we put in parentheses. First of all, we need to, well, actually, there's 4 things we put in the argument. This first thing we just need to know to keep track so we don't get heads and tails confused. So the first thing is the definition of the event, the outcome that interests us. We have to say what this P event is, and that is getting heads randomly when we flip a coin. The P event is getting heads. The second thing we need to know is N, the total number of events. In this scenario, we said, what's the probability of getting 3 heads with 7 coin flips? So we'd say N equals 7. So the third thing is the total number of outcomes that interest us, the number of P events. So we said we were interested in getting exactly 3 heads with 7 coin flips. So 3 heads means that the number of P events is 3. Now notice that this number of p events always has to be less than or equal than n. You can't say, oh, what's the probability of getting 8 heads with 7 coin flips? That doesn't make sense. You can't do it. You could say 7 heads with 7 coin flips or 0 heads with 7 coin flips, but it can't be greater than n. Then we have to know the probability of each of these events, and we call this p. And so the probability for getting heads is 50%. And then we have to know if it's cumulative or not. In this case, we want to know the probability of getting exactly 3 heads with 7 coin flips. And so that means it's not cumulative. We just want to know the probability of 3. If we wanted to know the probability of getting 3 or fewer heads, that would be cumulative. So when we go to Excel, we're going to ask a lot of varieties of this theme. We're going to start off with the question, what's the probability of getting exactly 3 heads with 7 coin flips? But then we're going to change it a little bit, and we're going to get, what's the probability of getting 3 heads or fewer with 7 coin flips? That's going to be cumulative. Then we're going to ask, what is the probability of getting less than 4 heads with 7 coin flips? And we're going to see that that's pretty similar to what we were asking before. We're going to look at what's the probability of getting more than 3 heads with 7 coin flips. So rather than looking at 3 and fewer, we're going to look at the opposite ends. And then what's the probability of getting 6 or more heads with 7 coin flips? We're going to look at the extreme end of one of the tables.